So in the past we use cross-section method, then in other we also use the section method from this side, from cross side and from the long side along with the box culvert. So today we will use from the surface. Suppose this is our natural ground and we excavated like this with side slope, as you can see in the picture, with the working space and side slope. We cut it from this natural ground to this bottom level. So we will come here. Now you can see this is my natural ground. I will copy this picture so you will understand better here. So this level is this natural ground. Now how I will draw. Suppose our box culvert is like this. This is, and the road is passing like here, and this the culvert is like crossing. So I will take first from here the working space 50 cm. 50 cm on the both side. I will take offset 50 cm. Yes, this drawing is not on scale, but I will try to make this like 50 cm offset on the both side. So then as you can see there is a side slope. We cannot excavate vertical, so we are excavating in slope. I will draw in GL so you will understand. Suppose this is our natural ground level and this is box culvert. The box culvert I will take offset, as it is not on scale, so it's not the thickness of the wall is not clear. I will draw working space 0.5. As you can see it's very small, so I will increase the size, or I will increase the working space size so you will clearly visible. Okay, on the board side it's not on scale, just for practice. There is a vertical side slope. In slope, let's say the side slope are 1:2. Mostly the side slope are 1:1, 1:2, as you will take from your construction drawing or from your shop drawing. So I will just practicing on it. So let's say this is side slope. In this we will excavate this to the natural ground. Maybe the slope is going outside the natural ground, so I will extend this one, and now it's touching. So like this we will excavate on both sides, as you can see in the picture also. Like this we will take excavation. This is our natural ground level. Okay, so now we need the excavation level for this surface also, because we will calculate volume between the natural ground and the excavated ground. So I will take offset without adding scale. Suppose our excavation, the side slope is this point and this point are the points on the both sides. So let's take the surface is our natural ground before the excavation. So I will rename it so you will easily understand which one is the natural ground. I will change the name from TRSPU to natural ground, and now I will create point for the excavation, because these points were bring by the surveyor from the side after the excavation, before the excavation. So these are the these points, that the bed level are these points. So we will create points on each of the corner of the bed. You will not create this point, this will bring by the surveyor, and this the edges which will touch the natural ground here and here. So but like this will be excavation point, but if a surveyor will not bring, you can draw your drawing exactly on the scale, and then you can draw like this, and you can also calculate the quantity, excavation quantity. But mostly for us, the surveyor bring from the side is we say it's on the side. They check with the consultant surveyor, and then they bring to us, and we can compute volume from this surface. Okay, so I will add this point to a group, a separate group, because I will make surface from this group. Now as you can see, there is zero elevation in all the points because I created it manually. So I will select these points and I will take elevation for the outer edge. The natural ground is correct elevation because it will touch the natural ground. So I will take as elevation from the natural ground. So as the outer edge, it will touch the natural ground here. So automatically the level will come from the natural ground. This point I need the bed level. The bed level is this level. It will come, let's say it's 2 meter down from the natural ground. So I will minus 2 meter from this elevation. Okay. So if you want, you can change one by one, like 2 meter from here, or the better way, the bed level is always the same level. All from the side is the same level, so you must put exactly the one level in all the four sides of bed, because bed is the same level. So what will I do? I will copy this elevation and I will paste this in all the four sides of the bed. If there is slope in the bed, you can calculate according to the slope. That's why I am saying the surveyor. If surveyor bring the data from the side, it will be 100% correct. So now these points have the right elevation what I need. Then now I will create a surface from this point. Let's say I will rename this as a box culvert, bed level or excavation level. You can write what you want to write. There is excavation level, but the slash it will not accept, so I will remove slash here. Okay. Now I will add this one group to this surface. That's why I create a separate group for these points. So as I select the surface, I want to see if it is surface is created from exactly the points what I need. So I will decrease the interval level between the contour, and now as you can see the contour have created and exactly the shape for the excavation of the box culvert is made here. You must take the 3D view of this excavation. Sometimes there is some error, or you can create a quick profile for what you make here. I will remove the other surface because I need only two surfaces. So So now this is the natural ground, and this excavation level or finished ground level. So this is the natural ground, this the same like this, same shape. Now let's go to analyze step, volume dashboard, and then create surface. Let's take right here method 03. Compare surfaces always the first surface before excavation and then the last surface after excavation. And as you can see, the cut value, that's all it has. Maybe some point there is 0.27 fill, but it almost cut. So 2660, it is the cut value. I will scale this, and now you can print this for the quantity or attach with the request. So like this, you can calculate the volume from two surfaces of excavation. Okay, so this was the third method, how you can calculate volume for excavation. Let's now try the first and the second method. We have created in the assemblies the shapes of the sub-assemblies. So we will try here this. I have created sections, so I will just change the assembly here. I will create another new assembly. Let's say this method 1. I will insert the first method for which I have created. I think the box culvert with wings wall I created this one. So yes, this was the first one. And then the second one we have created. Let's name it method 2. I will insert subassembly here. Okay, so now copy the side slope or daylight from the assembly, the right side. I may move this here or above. It's better here. Then the left side, copy the left side. Okay, so for the first method, let's change the assembly in the side the cross section. First, I will go to the parameter. From here, I will change the assembly. Method 1. I don't need the surface to connect the surface. Let's add here. As you can see, it's working. The box culvert section is clearly shown here, and it's calculating the volume also for cut and fill. Okay, now let's check the other one from the long side. For which I have created assembly method 2. I will change the assembly method to now check the cross section. It's also working properly, and as you can see the line passing under the datum line which we have coded. So as you can see, passing through exactly where the datum line, and it's also calculating the value. So like this you can calculate the value for excavation in three different ways: the first method, then the second method, and then the third method. Hopefully you will practice on it. Okay, thank you.